Binomial theorem. The binomial theorem states that if n is a positive integer, then for all values of x and a, we have that x plus a raised to the power n is equals to s raised to the power n plus n combination 1, x raised to the power n minus 1a plus n combination 2, s raised to the power n minus 2 a square plus n combination 3 s raised to the power n minus 3 a raised to the power 3 plus, keep on going, to a raised to the power n. So if we have an algebraic expression that is raised to the power of n, we can express it in this form. Now let's proceed to example 1. Expand s plus 2 all square using binomial theorem. So from the question, we are going to expound s plus 2 square using binomial theorem. Recall that binomial theorem states that s plus a raised to the power n is equals to s raised to the power n plus n combination 1 x n minus 1a plus n combination 2 x n minus 2a square plus n combination 3 x n minus 3a cubed plus, keep on going to a n. How do we apply this with this expression we have here, which is x plus 2 or raised to the power of 2? Now this is equals to. Now when we compare this expression with this one, we have that s is x and a is 2, n is also 2. So we have that x raised to the power n will be x raised to the power 2 because n here is 2 plus n combination 1. Recall that n is 2, so this is 2 combination 1 x n minus 1, which is 2 minus 1 a, and a is 2 over here, so here will be 2 plus n combination 2, n is 2, so it's 2 combination 2 x raised to the power n minus 2. Remember that n is 2, so it becomes 2 minus 2 a square, since a is 2, so it becomes 2 square. We must take note of something, that we need to know when to stop. Although we have a continuation series here, but knowing to stop is very important. So when do we stop? We stop at the point where x is raised to the power of 0. So as we are moving forward, if we observe that x is raised to the power of 0, we stop there. For example, right here we have that x raised to the power 2 minus 2. And of course, 2 minus 2 is 0. So it means we must stop here. We don't need to proceed to n combination 3. No, just stop here. So let's proceed now. This becomes x squared plus 2 combination 1 x raised to the power 1, because 2 minus 1 is 1, then times 2 plus 2 combination 2 x raised to the power 0, then 2 raised to the power 2 is 4. Now we need to simplify this further. It's going to give us s squared plus 2 combination 1. We need to remember that when dealing with combination, that n combination arrow is equals to n factorial all over n minus arrow factorial. Well, if you want to learn more about combination, just click on the link at the top of the video and it will lead you straight to a video that deals with combination. So for the meantime, 2 combination 1 is equals to 2 factorial all over 2 minus 1 factorial, 1 factorial. Then we have x raised to the power 1, which is x times 2, plus 2 combination 2 is 2 factorial all over 2 minus 2 factorial 2 factorial. S raised to the power 0 is 1 times 1. Then we have 4 here times 4. Now let's simplify this further. This gives us x squared plus 2 factorial all over 2 minus 1 is 1 factorial 1 factorial. X times 2, which is times 2x, plus 2 factorial all over 2 minus 2 is 0, 0 factorial 2 factorial. Then 1 times 4 is 4, which is times 4. We have x squared plus 2 factorial is 2, which is 2 times 1. So it's 2 times 2x all over, this is 1 factorial is 1, 1 factorial is 1, so all over 1, plus 2 factorial is 2, and 2 times 4 is 8, or let me just write 2 for 2 factorial times 4, all over 1, 0 factorial is 1, times 2 factorial is 2. So from here, 2 will cancel 2. So if we move over to the next page, we have x squared plus 2 times 2x plus 4. So this is what we have now. If we simplify further, it becomes x squared plus 4x plus 4. So this is expansion, which implies that x plus 2 all squared is equals to x squared plus 4x plus 4. Now to check if one side is correct, we can decide to expand this bracket raised to the power 2, and this gives us x plus 2 into x plus 2. If we expand the bracket, which is x into x plus 2 into x plus 2, this is x squared plus 2x plus 2x plus 4, which is x squared plus 4x plus 4. So expanding this expression using binomial theorem gives us x squared plus 4x plus 4. Let's proceed to example 2. In example 2, we're going to use the binomial theorem to expound 2x plus 3 all raised to the power of 4. So the expression we're going to expound here is 2x plus 3 all raised to the power of 4. But remember that x plus a also raised to the power of n, according to the binomial theorem, is s raised to the power n plus n combination 1 x raised to the power n minus 1a plus n combination 2 s raised to the power n minus 2a squared plus n combination 3 s raised to the power n minus 3 a raised to the power 3 plus we keep on going to a raised to the power of n. Now let's apply this while expounding this expression. 2x plus 3 all raised to the power of 4 becomes x raised to the power n. Since x is 2x, becomes 2x all raised to the power of n. N is 4, so here's 4 plus n combination 1. Since n is 4, so it becomes 4 combination 1 x. This x here is x, and x is 2x. 2x all raised to the power n minus 1, which is 4 minus 1. Then a, here a is 3. A is 3, so this is times 3. Then plus 4 combination 2 x raised to the power n minus 2. N is 4, so it becomes x raised to the power 4 minus 2. A square, a is 3, so this is 3 square, plus n combination 3. Since n is 4, so it is 4 combination 3. S raised to the power n minus 3, s is 2x, so this is 2s raised to the power n minus 3, n is 4 minus 3. Then a raised to the power 3, a is 3, so this is 3 raised to the power of 3. But are we going to stop here? No, remember that we're going to stop at a point where the power of x is 0. Now, what's the power of x here? This is 4 minus 3, so the power of x here is 1. So which means we will not stop. If you observe, the sequence continue. Now, what is the rule of the sequence? This is n combination 1, n combination 2, n combination 3. So obviously the next one will be n combination 4. So this is plus n combination 4. N is 4, so it becomes 4 combination 4. Then this is x n minus 1, s raised to the power n minus 2, s raised to the power n minus 3. So the next will be x raised to the power of n minus 4. And x is 2x here. So which is 2x raised to the power of n minus 4, which is 4 minus 4. Then is a squared, a raised to the power 3. So the next is a raised to the power 4. Since a is 3, so it becomes 3 raised to the power of 4. Are we going to stop here? Yes, because 4 minus 4 is 0. Now remember, when the power of x is 0, we stop at that point. Now let's proceed. 2x plus 3 all raised to the power of 4 gives us 2x raised to the power 4 plus 4 combination 1, 2x raised to the power of 4 minus 1 is 3 times 3 plus 4 combination 2, 2x raised to the power 4 minus 2, which is 2x raised to the power 4 minus 2 is 2 times 3 squared is 9 plus 4 combination 3, 2x raised to the power 4 minus 3 is 1, x raised to the power 3 is 27 plus 4 combination 4, 2x, 4 minus 4 is 0 times 3 raised to the power 4 is 81. So we need to simplify this expression further. This will give us 2x plus 3 all raised to the power 4 is equals to 2 raised to the power 4 is 16, s raised to the power 4 is s raised to the power 4 plus 4 combination 1, that will give us 4 factorial into 4 minus 1 factorial 1 factorial times 2 raised to the power 3, which is 8 s raised to the power 3 times 3 plus 4 combination 2. So 4 combination 2 is 4 factorial all over 4 minus 2 factorial 2 factorial. Then 2x all square, that will give us 4x squared times 9 plus 4 combination 3. Now 4 combination 3 is 4 factorial all over 4 minus 3 factorial 3 factorial. 2x all raised to the power 1 times 27, which is 2x times 27 plus 4 combination 4. 4 combination 4, that will give us 4 factorial all over 4 minus 4 factorial 4 factorial. 2s raised to the power 0, anything raised to the power 0 is 1, so this is times 1 times 81. Hence 2x plus 3 all raised to the power of 4 becomes 16s raised to the power 4 plus 4 factorial all over 3, 4 minus 1 is 3 factorial, 1 factorial, 4 factorial all over 3 factorial times 1 factorial. 8s raised to the power of 3 times 3 times 8 times s raised to the power of 3 times 3 plus 4 factorial all over 4 minus 2 is 2 factorial times 2 factorial times 4s squared times 9 plus 4 factorial all over 4 minus 3 is 1 factorial times 3 factorial here, 2 times 2x times 27 plus 4 factorial all over 4 minus 4 is 0 factorial into 4 factorial times 81. So let's simplify this further. This is 2x plus 3 raised to the power of 4 is equals to 16s to the power of 4 plus 4 factorial is 4 times 3 factorial. We stop at 3 factorial because the 3 factorial here, and then we eventually cancel out, times 8 times s to the power 3 times 3 all over 3 factorial plus this is 4 times 3 times 2 factorial. We stop here because there's 2 factorial here times 4x squared plus 9 times 9 all over 2 factorial times 2. 2 factorial is 2 plus 4 factorial is 4 times 3 factorial times 2x times 27 all over 3 factorial. Since 1 factorial is 1, I don't need to write it. Plus, from here, 4 factorial just cancel 4 factorial. 0 factorial is 1, so we're left with 81 here. There are some terms that can cancel out. For example, 3 factorial cancel 3 factorial, 2 factorial cancel 2 factorial, 2 we're going to 4 2 times, 3 factorial cancel 3 factorial. So the expression becomes easy. We have that 2x plus 3 all raised to the power of 4 will give us 16x squared plus, let's see, here we're left with 4 times 8 times 3, 4 times 8, that is 24, 24 times 3 is 96, x raised to the power 3. So this is 6x raised to the power 3 plus, the next term is 2 times 4, that is 2 times 3 is 6, 6 times 4 is 24, and 24 times 9 is 216, x raised to the power 2. 216 x raised to the power 2 plus 4 times 2 is 8, 8 times 27 is also 216, x. 216x plus 81. And this is the answer. If we expand this, we'll have this as the answer. So the binomial theory is easy, although it's kind of lengthy. You must be very careful not to miss a number, then you usually get your answer. So the advice is to practice. You can pick out any algebraic expression that has power and try to expand them. You can expand them using the number expansion method and compare with that of the binomial theorem and see if your answer will match. If you want to learn more about binomial theorem, if you have any problem, you can send me the question on WhatsApp. I'll be glad to solve it for you. Meanwhile, subscribe to my channel, like and share my video. I will see you in the next video. Bye.